Okay, hello. This should start our week number 3, I believe. And this is the last week before spring break, so after Friday, you'll have a week off and you'll get to stay in your house a little bit more, probably. But this week, we're just going to focus on a few more types of quadrilaterals. So we're going to start with rectangles, and then we'll get into some squares and rhombi later throughout the week. So starting off with rectangles, we have some more properties that deal with rectangles. But first, we still have to remember all those parallelogram properties because rectangles have all those same properties as well. So a lot of you, I could tell, were getting your properties from Google and you were not using these, so make sure you're using these properties and not the ones from Google, because Google has one about if one angle is right, then all the angles are right, and that's not, that is true, but that's not true for all parallelograms. Like, that's more specific for just, like, rectangles and squares. When we get into talking about rhombi and other sorts of things, then you kind of lose what a parallelogram actually is, I think. So make sure you're just focusing on these properties and none other, okay? So if I get rid of all these markings I just made. So parallelograms, those are the properties there. We have two more. So it follows opposite sides are congruent, opposite sides are parallel, all of those that you can read. They also, this is when they talk about those 4 right angles. So all the angles in a rectangle are right angles. So all 4 angles are right angles. Okay, the second thing that's kind of new is that the diagonals are congruent. So not only are they bisecting each other, but they're also going to be congruent. We didn't always see that with parallelograms. So diagonals are congruent. So using those, we're going to do some problems with a bunch of different types of rectangles. So I'm going to do all the odds, and then you're going to do the evens, okay? So for number 1, it looks like I'm just finding side measures, so I'm not even thinking about angles right now, I'm just thinking about sides. So we know that rectangles, the pairs of opposite sides are congruent. Okay, so that means I can make all of these tick marks. Okay, so if I find SR, SR should be congruent to PQ, so that means SR is also 24. Okay, then QR, okay, so QR is the opposite side to PS. See that? PS, QR, so that means QR is also 10. And then, now I'm going to look at SQ. So SQ would be one of these diagonals. So I don't know what SQ is or PR, because if I knew what either one of those were, they would be the same thing. So instead, I'm going to have to just think about looking at a triangle. Remember right triangle trig? Or just Pythagorean theorem? So now I have, if I were to draw this as just a triangle, I would have a right triangle, because angle P is a right angle. This would be 10, and then one of my legs would also be 24. Now that diagonal SQ is what I'm trying to figure out. That's like my C in the Pythagorean theorem. So if I take 10 squared plus 24 squared, it should equal whatever SQ is squared. Okay, so 10 squared, I get 100. 24 squared, I get 576 equals SQ squared. You could just leave it as x squared. So then I'm going to take 626 equals, I'm going to turn this into x squared. Then to get x by itself, or to figure out what SQ actually is, that's when you take the square root. And so then x equals 26. So I just figured out this diagonal is 26. So SQ is 26. And then PR, that's that other diagonal, they're congruent. So that's also 26. Then I need to find QT. Okay, so QT is just half of that diagonal. And I know that the diagonals bisect each other because that's one of the parallelogram properties. So I'm just going to take half of whatever this diagonal is. So half of 26, I would get 13. Okay, so number 1 is just the side lengths. Now if we go to number 3, 3 is dealing with all angle measures, okay? And again, you can see that by, it says m, the little m, measure of angle, and then it gives an angle. So all I'm really given, though, is this 27 degrees. If I wanted, I could go and figure out what all angles are congruent to this 27 degrees. So I have that angle and that angle, because those two green angles are those alternate interior angles that we've been talking about. But also, if I think about these diagonals are making isosceles triangles because these two diagonals are the same length when they get bisected, and then these guys should also be the same length. Okay? Because those diagonals are congruent and they're bisecting each other, so what's happening is they're forming, this is an isosceles triangle, this is an isosceles triangle, here and here. So 4 isosceles triangles. So that being said, I'm going to match up all the angles that I could. That would also be 27. So if I just look at this triangle up top, that means this angle would also be the base angle in that isosceles triangle. So it should be congruent. And then if I look down here, this angle would be congruent. Okay? Now this makes it a little bit easier, I think, because I can already see, like, oh, all those green angles should be congruent. And if I wanted to keep going, if I thought about this angle, this red angle, should be congruent to this guy. The same idea. If we think about, if I went down here and I just compared this guy to this guy, those would be alternate interior angles as well. And then I could keep going. And there's a good start, okay? So when I look at finding the measure of MJK, so MJK. Okay, well that one's easy because that's just one of the angles in the rectangle, which all 4 angles have to be 90 degrees. So angle MJK, that's just going to be 90 degrees. Then, when I'm looking at measure of angle MJL, okay, so MJL would be this red angle here. Now I know that this red angle plus this green angle would make that 90 degrees. So I'm going to figure out what plus 27 would get me that whole 90 degree angle. So if I take 90 minus 27, I would get 63. So that means all of these red angles are 63 degrees. So hopefully that makes everything else a little bit easier. Measure of angle JLK. JLK. Okay, JLK, that's another red angle. So that's also 63 degrees. Now I'm going to find angle KML. KML. KML, that's a green angle. Okay, see how the color coding helped a lot? So that means this green angle up top is 27. So KML is also 27 degrees. Alright, this last one, angle MNL. MNL. Okay, so that is one of the angles that we know nothing about. But luckily, if we just think about looking at one of these triangles, specifically this one, if we just break this down into one triangle, I know that this green angle is 27 degrees and this green angle is 27 degrees. Well, what do all the angles in a triangle have to add up to? Well, 180. So if I take 180 minus 27 minus 27, that should give me that last remaining angle that I'm looking for. So 180 minus 27 again is 126. There you go. A hint for number 4. Number 4, you're dealing with angles again. I would really focus on the fact that these are all, like this triangle and this triangle are congruent, and they're all isosceles triangles. So that means that this angle and this angle have to be congruent, okay? That's as much of a hint I'm giving you. If I look at number 5. So 5 I'm going to mark up really fast, and then come back. So, alright, so I think I have everything marked up. If I think about AC is that other diagonal. So I already know DB is one of the diagonals, so both of those have to be congruent. So AC is also 42. EB is half of this diagonal, so I have to think about what is half of 42 because these diagonals are bisecting each other. So I'm going to take 42 and divide by 2, and I get 21. And then BC is the opposite side to AD, so BC is also 26. And then AB is opposite of DC, but I don't know what DC is. So now I'm going to have to think about Pythagorean theorem, because if I look at just this triangle, or one of these triangles, I now have a right triangle. So I'm going to do Pythagorean theorem, and I'm going to have AB is one of my legs. So I'm going to have x squared plus 26 squared equals 42 squared. Okay? And when I square 26, I get 676 equals 42 squared. My turtle is making some noise. 1,764. Then I'm going to subtract 676 to get x by itself. And I get x squared equals 1,088. Oops. And then I'm going to take the square root. And so I get x equals 33. That 33 is that leg that I was trying to figure out, AB. Alright, I'm going to erase that. Now I'm going to think about my angles, so I am going to get rid of all my side measures because those aren't very helpful for the angles. Alright, the only angle I know is angle DEA, and so that's the blue angle that I have right there. If you want to go ahead and fill in, this should be congruent, then this would be congruent, and this would be congruent. There's my isosceles triangles again, and if I kept going, maybe green, 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 green. Alright, so angle ADC, okay, so ADC is just one of the right angles in the rectangle, so I'm going to have 90 degrees. There's my right angle. Then angle ABD. ABD is one of those green angles. I don't know what those green angles are yet, but I have this blue angle plus this green angle should equal 90. So I'm going to take 90 minus 52, and that's going to give me whatever this guy is, which would be 38. And so I know this angle is 38, and then all those other green angles are also going to be 38. Now I'm going to find angle BCA. So BCA is a blue angle. Hopefully you guys like the color coding. I think it helps me at least stay focused on what I'm trying to find. So the blue angle is 52. That was from the very beginning. So that means this angle is also 52 degrees. And then last, I think I'm going to find this middle angle. Yep, DEC. So this is like when we found this angle up here. I have a triangle. It's specifically an isosceles triangle, and these two angles down here are both 38. So I'm going to take 180 minus 38 twice to get rid of both of those green angles. 38 minus 38 equals, get 104 degrees. Alright, so I'm going to move to the back page. I think there's only a few more. So the back deals a lot with like more algebra based. The front is more just like using all those properties. So the back shouldn't be too bad, quite honestly. Number 6, you just have two sides. So CD and FE, those are opposite sides, so they're congruent just like in a parallelogram. So I'm going to have 3x plus 5 equals 7x minus 39. Add 39 to both sides. You get 3x plus 44 equals 7x. Subtract 3x. 44 equals 4x. I'm running out of room. Divide by 4. And x equals 11. That's probably one that you guys probably could have done on your own. Number 8. If JM equals x plus 17. So let's figure out where JM is. JM, I'm going to highlight it red. Here's JM, so that's just part of a diagonal. And MK is 5x minus 2. MK is here. Oh, 5x minus 23. So what's happening is, again, we have to look at those triangles. And I told you that the diagonals are bisecting each other. So not only are they making this HM congruent to MK, so if only we knew what HM was, then we could set that equal to MK. But the good thing is, both of these diagonals are congruent to each other. So if you split one of these in half, it's going to equal the same half as if you split the other diagonal in half. Hopefully that makes some sense. I'll try to mark this up again, but this will be congruent to this, and since this diagonal is the same length as also this diagonal, I'm just creating two more of the same halves. So all of those diagonals, if I broke them up into 4 separate pieces, they should be the same thing. So to solve this, you're just going to set x plus 17 equal to 5x minus 23. So add 23. And I get x plus 40 equals 5x. Subtract x. 40 equals 4x. Divide by 4. And x equals 10. Now, I almost forgot to do the rest of the problem. Find JL. So JL would be this whole diagonal. So I could figure out what just 1/2 of this diagonal is and just multiply it by 2 at the very end. So I'm going to take, let's do JM. So 10 plus 17, I get 27. If I multiply that by 2 or add another 27, either way, I'm going to get JL equals 54. Okay, moving on to number 10. In 10, I have find measure of angle BCE. So BCE is right here. Okay, I don't know anything about that angle. I'm just told something about angle DCE and angle BAE. But what I could tell about those two angles I'm given equations for is that they are congruent because they are those alternate interior angles. So if I color in this angle right here and this angle right down here, I could say those two are congruent, and then I could actually figure out what x is and plug in for x and solve. Okay, so I'm going to take 7x, oh, I don't want that, 7x plus 5 equals 11x minus 3. Add 3 to both sides. 7x plus 8 equals 11x. Subtract 7. Really 7x. 8 equals 11 minus 7. Wait. Yeah, 4x. Divide by 4. And x equals 2. Alright, now if I take x and I plug it back into, let's say, this angle right here, I would have 11 times 2 minus 3. So 22 minus 3, and I get 19. So if I know that this angle is 19, I would also know, again, I'm making two different isosceles triangles. This angle down here is also 19 degrees. I could also figure out, if this is a 90-degree angle, what this green angle would be. Whoops, I want that to be the highlighter. So figuring out what that green angle is might be a little bit more helpful. There's quite a few ways you can go about this one though. So I'm going to figure out what that green angle is by doing 90 minus 19, and I get 71. So this angle right here is 71 degrees. Because this is also an isosceles triangle, this base angle is 71 as well. I'm trying to find BCE. Oh, I've already found it. See, that's what happens when you try to do too much. You're forgetting what you're finding. So angle BCE is just that green angle that I just found, and now I just made it red. So measure of angle BCE equals 71 degrees. There you go. Alright, so in this one I'm finding the measure of angle XZW. So XZW, that would be this red angle down here. I do know that red angle would be congruent to this guy because of alternate interior angles. But then if I look at this other angle they give me, that green, those are not going to be equal angles. I don't know if they're actually equal or not. I could say that these two green angles are equal though, because of alternate interior angles again. So now let's rewrite what that green angle is up top here. It's x plus 20. And I can write that because those are both congruent angles, and if they're both the same thing, then they both should equal this x plus 20. Now looking at this green and red angle, that's making up one of these right angles in this triangle. Or not triangle, this is a rectangle. It's making up that right angle in this rectangle. So if I take this angle plus this angle and set it equal to 90, I could solve for x. So I'm going to try that. So I'm going to have x plus 20 plus 5x minus 8 equals 90. And then I would combine like terms, so I get 6x plus 12 equals 90. Subtract 12, and I get 6x equals 78. Divide by 6. X turns out to be 13. I'm not done yet though, because I want to find angle XZW. Angle XZW, that's this red angle. So this red angle would be congruent to this first red angle, which is 5x minus 8. So if I plug in x here, I could figure out what XZW is. So I'm going to take 5 times 13 minus 8, and I get 57 degrees. So measure of angle XZW is equal to 57. Alright, so once you complete all the rest of the problems on this page, so 2, 4, 7, 9, 11, and 13, you can take your attendance quiz for the day. There'll be random questions about your answers to all of these, so make sure you do all of them before you start that quiz. I hope you guys are doing well. Hopefully I've posted something about the Google Hangout or Google Meetup, so if you want to ask me questions while you're going through these, like, I'm more than willing to help, and I'll try to be there as much as I can. Miss you guys, hope you're doing well. Just 4 more days, however you want to look at it, till spring break, okay? So hang in there. This stuff really does count. Alright, bye guys.